Hello, this will be a demonstration of Proposition 10 from Book 7 of Euclid's Elements, which says that if a first number be the same parts of a second number, that a third number is of a fourth, then whatever part or parts the first is of the third, the same part or parts shall the second be of the fourth. So this is like the previous proposition 7-9, but instead of being given that one number is the same part of a second, that a third is of a fourth, we're given parts. What we're given is that the number AB is the same parts of the number C, that the number DE is of the number F, and what we're going to prove is that alternately, whatever part or parts the number AB is of the number DE, the same part or parts shall the number C be of the number F. Now, because the number AB is the same parts of C that the number DE is of the number F, we can then divide AB into parts such that each one of those parts is just a part of C, and we'll have the same number of such parts in DE. So we're going to have the numbers AG and GB each be a part of the number C, and we're going to have the numbers DH and E and HE each be a part of the number F. Now, because the number AG is the same part of C, but the number DH is of F, that comes from a combination of the given and simply how we created the numbers AG and DH, then by proposition 7-9, we can alternate this relationship and say that whatever part or parts the number AG is of the number DH, the same part or parts shall the number C be of the number F. We can say similarly that whatever part or parts the number GB is of the number HE, the same part or parts shall the number C be of the number F. So that in totality, if we add these together, then whatever part or parts the whole AB is of the whole DE, the same part or parts shall the number C be of the number F. And this is precisely what we set out to prove, which means we are done with the proposition, therefore, etc., Q, E, D. An example of this would be that 2 is the same parts of 3, that 4 is of 6, and so we can alternate this and say that 2 is the same part of 4, that 3 is of 6, and this is obviously the case. 2 is 1/2 part of 4, and 3 is 1/2 part of 6. Alternatively, if we have that 4 is the same parts of 6, that 10 is of 15, then alternately we can say that 4 is the same parts of 10, that 6 is of 15, namely 2 1/5 parts. 4 is 2 1/5 parts of 10, so each 1/5 of 10 is 2. 2 times 2 is 4. And similarly, 6 is 2 1/5 parts of 15, namely that it's 2 3s, and 3s are 1/5 of 15. So that with this example, we see that this proposition holds. That's all I've got to say about this proposition, so I'll end the video here and move on to 7-11.